Hi folks, the topic we're going to be covering today is based on surface geometry, and specifically under surface geometry the area of roof geometry. Now in this area of roof geometry what we're going to be learning about is the angles that are created between surfaces, and that is something that is known as the dihedral angle. Dihedral angles are very important and they come up most years in the Leaving Cert exam. And essentially what it is the angle that is created between two surfaces. So if we look here at surface A and surface B, where they meet obviously here at this line here, which will be known as the line of intersection of those surfaces, or where surface B meets C, which would be the line of intersection here. What that is going to actually create is an angle that is in between those surfaces. Once again, that is known as the dihedral angle. And we're going to be learning about the methods to actually find how to work out what that angle is. So just given the question here, we can see the plan and elevation of the solid are given. It says, part 1, use the rebatment method to determine the dihedral angle between surface A and surface B. And part 2, determine the dihedral angle between surface B and C using the auxiliary views method. So there's actually two methods we can use, and we're going to practice both of them on this question. The first one, the rebatment method between surface A and B, and the second one between B and C, which is the auxiliary views method. Okay, but before we get onto that, I'm just going to flash to Solidworks for a moment, and I have a little graphic model laid out here of this. It's obviously not 100% accurate, but it gives the representation of it, and what we're going to do is just discuss a little bit more on the dihedral angle. Okay, so we can see that we have the model here, which is the same as off our sheet. The red surface here signifying surface B, and the yellow surface signifying surface A. And what we want to do is we want to find the dihedral angle between those two surfaces, so the angle created where those two surfaces meet. First of all, I'll just flash to the orthographic so you can see kind of what it looks like on our sheet. We obviously have the elevation we're given, and we're given the plan, and obviously we've got the two more views over here. But I'll just go back to the original here now and into the pictorial view. So as I said, the dihedral angle is the angle between the line of intersection of two surfaces. So we've got the yellow surface here and the red surface. And we have here, this line where they meet is known as the line of intersection. That is very, very important. To be able to see the dihedral angle, we need to see the line of intersection as a point view. Okay, so I'm just going to rotate up there as best I can. And you'll see here, I'll zoom in a little bit. And what we can do is we can see the line of intersection is still there between the two surfaces, but we need to see that line as a point. So I'm just going to rotate up. There we go. And at this point here, we see the line of intersection as a point view. And this line here would be the yellow surface, and this one would be the red surface. And the angle created between them is what is known as the dihedral angle. Okay. Now, going about this question on our sheet, there's a couple of ways we can go about it. But what we first have to do regardless is we need to see this line of intersection as a true length. So I have a plane set up here which will show that. I'll just turn it on there. So I have the plane turned on there now, and it is the true length. It's just going to show that line of intersection as a true length. So what I'll do is I will look perpendicular to it, so I'm normal to it. It's after flipping up the model upside down, doesn't really matter. But what we can see here is we now have this line here, this edge. I know we can only see the red face, the yellow face on the opposite side, as we can see there. But we can see that face there. If I just go normal to again, that line there is the true length of that edge, the line of intersection. That is the true length of the line of intersection. Okay, the next thing we would do on our sheet is we would create a cutting plane. Okay, so to locate the dihedral angle, we would need to have a cutting plane that cuts through perpendicular to the line of intersection. So as we can see here, we have a line. We need to have a cutting plane that cuts through perpendicular to that, which I have set up here. So I'll just turn that on now. And there we go. We can see now line of intersection was here, and I have a cutting plane cutting through it. And that cutting plane is going to cut away at this corner here. And that should reveal our dihedral angle. So I will unsuppress that corner, and that corner is now gone. And if I go to the cutting plane and I look perpendicular to it, we can see the angle created. There's our line of intersection as a point view, and the angle created where that cutting plane cut through it is the dihedral angle. Okay, and I'll flash out there, and that's what we kind of see. There's a 3D graphic of it there, but what we see there is the dihedral angle inside in there. But once again, we need to be looking perpendicular to our cutting plane there. Sorry, wrong one there. There we go. So there is the dihedral angle. Okay, so what I'm going to do now is I'm going to go back and we are going to complete the two methods on our sheet. Okay, so following on from that, what we are going to do now is we are going to complete the dihedral angle between the surfaces A and B, first of all using the rebatment method. Okay, and this method mightn't often be as used by students as much, but it's just as effective for locating the dihedral angle. Okay, so as I said previously, the first thing we have to do is identify the line of intersection between the two surfaces A and B, which is here, and what we need to do is we need to get that as a true length. Okay, so to get that as a true length, now there is a couple of ways. You could use the Cohen's principle, which we've previously done in developments. However, for this construction here, we're going to actually use an auxiliary view. Okay, so what I'm going to do is I'm going to project up perpendicular to the line of intersection, so we can see the line of intersection there, and I'm going to project up perpendicular to that. So I'm going to set up an x1, y1 parallel with it. So x1, y1, roughly somewhere about, I'm going to say about here. And that is called the x1, y1. Now that I have set up an x1, y1 parallel with the line of intersection, what I'm going to do is I'm going to project up. I have 2 points on that line. I have a point here which is on the ground, and I have a point up here which has a height here. Okay, so I'm going to project those up perpendicular. And there we go. That one obviously has a height, and this one here is on the ground. Okay, now I just have to work out the height of that point there. And that point there obviously matches up with this one in my elevation, so I'll just mark that. And what I'm going to do is I'm going to project up the height here. So if you project from the plan, you take your heights from the elevation. So there's the height that we need for that point. Mark it up here. Okay, now what I have got there is the line of intersection, but more importantly, I have the line of intersection as a true length. Okay, so that is the line of intersection. True length line of intersection. That line right there, from there to there, that is the true length of it. Now, when I was explaining in the Solidworks model, what I said at this point was we needed to make a cutting plane that was perpendicular to the line of intersection. Now that we have the line of intersection as a true length, what we're going to do is we can pick anywhere along this to create a cutting plane. Okay, so what I will do is I will line up my 45-degree set square on it, on the true length of the line of intersection, and then rotate it perpendicular to create a cutting plane. And about there, I'm going to create a cutting plane. And the angle inside in here is perpendicular, so it's 90 degrees. And essentially what we have done there now is we have identified actually 3 points. Without you might not realize this, but we've actually identified 3 points. First of all, we've identified a point on the line of intersection. Okay, technically that point, if I was to project it back, that point would be right there. I'm not going to use that right now because that's not exactly the point we're going to use in a minute, because what we're going to do is the rebatment method. But what I could do is I could identify this as well, and that is actually 2 points. That is actually a point on the surface A which is on the ground, okay, because that point has no height, so it has to be along the ground, and it is a point on surface A and surface B, okay, and it's going to be either here and here. Okay, so I'm going to locate those 2 points very first of all. So project them back, and what I have found is a point here which I'll label point 1, and a point here which I'll label point 2. And if they were labelled there 1 and 2, that would be 1 and 2 as a point view here. Now, we know that they join up to this point here, which I said was here. Okay, and if I was to put that in, okay, it would be an angle created there. The problem is that is actually our dihedral angle, but that is not the true shape of the dihedral angle. to see the true shape of the dihedral angle, what we're going to do is we're going to rebat it down, which basically means that we're just going to fold it down flat so that that dihedral angle is flat on the ground. Okay, so at 1 and 2, what we're going to do is we're going to put our pencil point here and rotate it down. And then at this point here, that is now on the ground but directly below our line of intersection, and that is where it's actually on the ground. And at that point there, we can now locate our line of intersection, or sorry, our dihedral angle. Okay, and that there is our dihedral angle, which is often identified by these little marks here. Okay, but that is the dihedral. To recap that, so what we did first of all was we looked perpendicular to the line of intersection, which was this guy here, and we set up an x1, y1 and projected out perpendicular at this point here and this point here. This point here was on the ground because it was here in our elevation. This point up here was the height we determined from this. Okay, and what we did then was we got the true length of the line of intersection and we created a perpendicular cutting plane that went through it. That is a cutting plane perpendicular, and that identified actually 3 points to us. It identified 2 points on A and B here, the surface A, which was point 1, and on surface B, which is point 2, and they are on the ground. Okay, so technically point 2 would be up here, point 1 would be up here somewhere. And it also identified to us a point that is cutting through the line of intersection, which was up here. And as I said previously, that was actually here at this point. But what we did was we wanted to get the true shape of that line of intersection. We want to see the true shape of that face. So essentially all we did was we rotated it down, or what's known as rebatted it down onto the ground. And when we rebatted it down onto the ground, we found the actual point on the ground. And we wrote and we projected it back here. And that angle inside in here, that angle is the dihedral angle by rebatment. Okay, so now what I'm going to do is I'm going to move on to the dihedral angle by auxiliary method between the surface B and the surface C. Okay, so the next part of this question was, once again, we had to get the dihedral angle, only this time between the surface B and surface C. And this time we weren't using the rebatment method, but we're going to use the auxiliary views method. Okay, so what we're going to do is project up an x1, y1 to get the true shape, the true length of the line of intersection between surface B and C. And very much like the last time when we did it over here, we're going to have an x1, y1, and we're going to take our heights from the elevation. First thing I will do is I'm going to label some of my points up, and I'm going to label the point here that's on the ground. I'm going to label that as point 1, and the point here at the top of the line of intersection, I'm going to label that as point 2. If I label it in plan, label it in elevation as well. So 1 and 2 right there. And once again, just to determine the height of 2, because 1 is sitting on the ground, that'll be the height of 2 there. Okay, now, so what I'm going to do, very much similar to what we did here, so I'm going to speed up the video to get the true length of the line of intersection up here. Okay, so now we have determined the true length of the line of intersection. What we are going to do is we are going to look at the line of intersection as a point view to get the dihedral angle between the surface B and C. Okay, and the way to do that is, what we're actually going to do is we're going to pick 2 points that are on the face of B and the face of C, but they share the same relationship. Okay, so to be able to do that, what I'm going to do is I'm actually going to pick a point. I'll actually pick it up here on my x1, y1. So I'm going to pick a point about right here. It doesn't matter, it could be here, it could be further out, as long as when I project it back that it will go through B and C. And when I project it back, obviously I'm projecting it back parallel. Okay, so when I project it back, that should go through B and C, and it does. So when I project it back, it's going through B here, and it's going through C here. And we obviously know that this edge here is on the ground and this edge here is on the ground. And at these points here, now I'm going to give them labels. I'm going to label this one number 3. I'm going to label this point here number 4. Okay, so up here then we would have 3 and 4 in the same position. Okay, now what we would do at this point here is I'm actually going to create, and if I join up 3 to 2, and 3 is already connected to 1, and then I also join up 4 to 2, essentially what I'm doing is I'm actually creating planes on the surface. So if I just shade in this 1, 2, 3 triangle here, okay, and now that I have them shaded in down in my plan view, I'm also going to shade them in up here in my auxiliary. So as I joined 3 to 2, I should do the same, and 3 and 4 are in the same position, they both join to 2. However, the colour that I'm going to shade it in on this side is blue, because when I look at it in this direction I see the blue face first. Okay, now what we're essentially after doing there is, it's like we're after essentially making 2 set squares is the best way I can actually explain it. So if I take my 2 set squares here, and what we're essentially doing is we're creating the line of intersection as a plane. And what we want to do is we want to get the angle between them, like that. If we join the 2 set squares together, we will want to see the dihedral angle between them. Okay? And that's essentially what we're after doing. It's like we're after tilting up 2 set squares here on top of each other, and they're joined on top, okay? And that is where they're joined is the line of intersection. And we see the line of intersection as a true length here. Now the only way that we can actually see the dihedral angle between that is to see the line of intersection. If we relate back to the Solidworks model, if we see the line of intersection as a point view. And the only way I could see this line as a point view is to look right down on top of it. I have to look straight along it. Okay? So I'm actually going to set up another auxiliary off this auxiliary. So what I'm going to do is I'm going to project down along 2, 1, the line of intersection, and I'm going to set up an x2, y2 that is perpendicular to it. So that angle there is perpendicular, and that's called my x2, y2. Okay, and I want to see the line of intersection as a point view. Now, to see that as a point view, it's very simple. From my x1, y1, I literally just take the distance back, because the distance from 1 to 1 is the same distance as, if you remember, it's not from up here, it's from the x1, y1 back, is the same distance as from the x1, y1 to 2. So we can see the distance from the x1, y1 back to 1 is the same as the distance from the x1, y1 back to 2. So that means then when we project it out here, 1, 2 was along this line here, projected out off the x2, y2. There we go. That means we now see the point here. This is the line of intersection as a point view. That is 1 and 2 in the same position. That's essentially like looking at a line and seeing it as a point. Okay, now what I need to do is I need to get 3 and 4 as well. Okay, so project down 3 and 4 parallel. They're along the same line, so they're going to be down along this line here somewhere, but all we have to do is we just have to measure from them back. So if I wanted to work out where 4 was, measure from the x1, y1 back. We always do one view back, and then from here, so that's where my 4 is going to be. And to find my 3, it's this distance. Hopefully it'll fit in my page. Might just about fit. Yep, just about. There's my 3. And essentially, if you remember, the line 1, 2, 3, 1, 2, 3 was actually the blue face, so I put that in with blue. Put it in with the pen first actually. So 1, 2, 3, and the line 2, 1, 2, 4, and the line 1, 2, 4 was the red face, so I put that in with red over it, and the line 1, 2, 3 was the blue. But what we have actually found inside there, here now, is the dihedral angle, which, as I said before, is usually signified with these kind of little arrowheads. So once again, the dihedral angle. Okay. So that there, guys, is the two methods for completing the dihedral angle between surfaces. The one over here was the rebatment method, where we got a cutting plane perpendicular to the line of intersection, and we rebatted it down to get the true shape of it in our plan view. And the other method, which is one that students often use, is literally a case of we did two auxiliaries. We got the true length of the line of intersection by creating an x1, y1 parallel to the line of intersection and then projecting up perpendicular. And then we looked along the line of intersection and set up an x2, y2 to see the line of intersection as a point view. Okay, so I'll just write that in there as well. LOI stands for line of intersection, and I put in point view. Okay, and then what we did was we had 2 points on the ground, 3 and 4, that shared the same relationship. They were at the same points, and essentially what we found then was them points down here, and we were able to create our angle. Okay, that is our dihedral angle inside in there. I hope you found that video helpful. That is the two methods there for completing the dihedral angle. Question complete.